Hello everyone, welcome to Hudson Engineering Academy. It's me, your tutor Hudson, and we're still continuing on our lecture series on shear force and bending moment. In this case, we're going to draw a shear force diagram and a bending moment diagram for this particular cantilever beam with a combination of point load and a UDL. Now, to start, for the case of a cantilever beam, we take our reference from this side. So we shall take it from this side and come this way. So what we do in this case is I will take my reference from this side, coming this side. So the span, my zero reference is here. So let me take the span 0 meter to 2 meter. That means this span of 0 meter to 2 meter will start from here, then come this side. Now, the first thing is know where to handle the beam from. So if I cut this beam from here, and I say the distance from here to here is x, we have to get the shear force. SFX is going to be equals to, the UDL is 1.5. So UDL value times the distance give you a force, and that is 1.5 times the distance x. This one is a force, but because this force is turning the beam, making the beam to go downward and clockwise like this, cantilever beam, it is taken to be negative. So that's what we take. So then that means if I want the shear force value, shear force when the distance is 0, at this point the shear force is also going to be negative 1.5 times 0, which is 0. Then the second case, shear force when my distance is 2, because I'm taking from 0 to 2 meter. So in that case, it is going to be negative 1.5 times 2. This answer is negative 3 in kilowatt Newton. I believe for the shear force within this span, it is done. I will also calculate for the bending moment within this same place. Bending what? Moment within this same span. Now, bending moment is a force times the perpendicular distance. So in this case, our force, we have already got it that it is minus 1.5x, because a UDL times the distance gives you a force. Okay, now this value of the force that we have, I have to multiply by half of the distance. Okay, because it's a UDL. The distance this UDL covers, this UDL is 1.5x. That is the force in terms of point load, as I discussed in the first video in this topic. So this point load, if you convert it, it acts at the center here. So that means it will act at half of what? Half of x. This distance, half of it. Okay? So that means a force is acting at half of x. Now this information is our bending what? Moment. So I have to get the value of bending moment when the distance x is 0. And this is going to be minus 1.5 times 0. Here is also 0. The whole of this is going to be what? 0. And then the second thing is get a bending moment when your x value is 2. So this is going to be equals to minus 1.5 times x squared. So the value of x is 2. And we have to square it because there is x times x. Then divide all of this answer by what? By 2. Okay? So you realize that this is 4. Then 4 when you divide by 2 is 2. So 2 times minus 1.5, the answer here still comes to minus 3 in kilo Newton meter. Okay? So we are done with the first span, shear force and bending moment. Now allow me take you to the second span. The second span is from, we are moving from here, 0 to 2 to 3 to 4. The total span is 4. So now I am here, done. So I will pick up from 2 meter to 3 meter. That means within this span, from here to here. If I cut this beam from here, okay? So forget about this one. We are done with it, okay? Forget about this one. So this beam, if I cut it from here, this span is what? Is x, okay? Now, which force do we have there? The force we have will be our shear what? Shear force. Let's say S of F. If that, I need to find it. But now, since I have only a UDL force, that side, UDL is minus 1.5. Okay? Now, UDL is covering the entire span, which is 2. Not to waste time to find just the value, just multiply this by 2. There is no another force. I am just multiplying a UDL value times the span in which it is covering. Why am I not multiplying by x? Because this is not being cut from here. It is cut from outside the UDL. So you only multiply by x when it's being cut from outside the UDL. That is for the case of shear force. Okay, I believe you have got that point. So this answer will still come to negative 3 kilonewton. Hope you're together. Now, what about the bending moment? So our bending moment in this case, BMX, is going to be equals to, I have a UDL, and this UDL is minus 1.5 and then times 2. That is what you need to know. This is a value of a UDL converted in terms of force. UDL times the distance. This is our force. Okay? So this force, forget about this one, we are done with it. This force on this span is acting at half of these two. Okay? So that means this minus what? Minus 3 is acting at half of these two. So what is the distance it is covering? The distance it is covering is from here up to what? X. Okay? So that means I need to multiply this to get the moment. I have to multiply the distance. This force, it is now, I've converted the UDL to a point load, and the point load is now here. So this point load times the perpendicular distance up to where I've cut the beam. So from here up to here is what I want as the distance. If I know that from here up to here is already X, okay? Then what about from here up to here? So the whole of this, which is X, minus this, the distance behind, which is, this is half of 2, so this is 1, so minus 1. So the total of this X minus this one, I will be remaining with what? This distance, which is what? X minus that one behind. Okay, so this is our expression for the bending what? Moment. I believe you have got it. So you need to take care of this. Know that convert this to a point load which is acting at this point. So this point load times the perpendicular distance where you're cutting the beam, this distance, and it is this one minus what is behind it. So it gives you this. So let's get the bending moment at X equals to, we are here. Remember, we're within this span. 2. So the first one is 2. So what is going to be this answer? Remember, this is negative 3 into X is 2. So 2 minus 1. So this is 1 times negative 3. The answer still remains minus 3 kilonewton meter, as you can see. But now there are two things. What about the bending moment when my X is equals to what? When my X is equals to 3. So this is going to be minus 3 into 3 minus 1. So this is 2. 2 times minus 3. The answer is minus what? 6 kilonewton meter. Okay. So we're done with that span. So we're left with the last span, which is from what? From 3 to 4, which is the last. Okay. So I believe you're getting this clearly. Let me just note this information for the first span here so that we can what? Carry over. So let's look at the span 3 meter to 4 meter now. That is from this part to the last part. Okay. So within this span, forget about this one now. We are done with it. Okay. We are done with it. So we cut this beam from here. And we are coming from this part up to what? Up to this. Well, so we call this one what? Our X. So what do we have? We have two forces, a UDL and a point load. So because I have the UDL, let me start with it. Shear force. Okay. What will be shear force X? So the shear force in this case, it's a UDL which is minus 1.5. Then times, what is the span? It is 2. I have converted this UDL value to a force. And since I want a shear force, that is okay. And then the next thing is, this force is done. The next thing is this force, 4 kilonewton. It is already a point load and it is pointing downward. So it is also going to be what? Minus. And minus what? 4. Okay. So this will be our answer. Okay. So minus 1.5 times 2, then minus what? 4. What is this answer? This answer is supposed to give you minus 7. This is minus 3, minus 4. So minus 7 kilowatt, kilonewton. Okay? Yes. And then we are done because there is no need to find or substitute. There is no another x. We move to the next. This will be the only shear force within this one span, and it will remain constant till that last end. So allow me take you to bending moment within this same span. So bending moment in terms of x, what will it be? Okay, I have a UDL. So a UDL is minus 1.5 times 2. This is the value of the UDL in terms of concentrated load, point load. So since now this is a force, it is acting at the center of this. What is the perpendicular distance from where it is acting up to where I've cut the beam? Okay, so this span is from here up to here. If the whole of this span from here up to here is x, okay, so if I need this one, if I need from here up to here, I have to remove this one away. So minus what? 1, because it is acting at half of 2. So this side behind is 1. Okay, so if I subtract that, then I will remain with the perpendicular distance from this where it is acting up to here. Clear? Yes. So the next force is 4, and it's downward, so it's going to be minus 4 times the perpendicular distance, the distance from 4 up to where I have cut this. Okay, this is what I want. If this is what I want, from here up to here is already x. Okay, minus. So since I want only this, so take away this other distance from here up to here. So minus, this is 2 and 1, this is 3. Clear? Yes. So if I remove this other distance behind, I will only remain with this x minus the whole of this behind. I remain with this distance. So this is the expression. I believe it is clear. Now let's find the bending moment when x is equals to, here is 3 meter. So you substitute. This is minus 3 into, this is 3 minus 1. You get that this one is 2. Okay. Then minus 4 into 3 minus 3. So this is 0. Okay. So the answer only is going to remain what? Minus 6 kilonewton meter. Okay. Minus 6 kilonewton meter. Then lastly, let's get the bending moment when x is equals to 4. This is going to be equals to, this is minus 3. Okay. Times 4 minus 1. 4 minus 1 is 3. Then minus 4 into 4 minus 3 is 1. So what do you get? Minus 9 minus 4. The answer is minus 13 in kilonewton what? Meter. So we have got all our answers. We just need to what? Draw it in a shear force diagram, bending moment diagram. We have this one and this. Then with the shear force, then the shear force of this one is this. Then for the first span, it is this for bending moment and this for the shear force. Well, so let us see how to put this into the drawing. In our first case, we found within this span 0 to 2 meter, the shear force is 0. Here, then at 2 meter, it is negative what? Negative 3. So I'll mark it here. Okay? Well, so mark it here. Good. Then from this span 2 meter to 3 meter, it remains constant. So up to this point, I'm marking. Then lastly, within the span 3 to 4, the shear span went to minus 7 kilonewton. So let's say it came down here to minus what? 7 kilonewton. Because this is a UDL, it is drawn using what? A slanted line. So that means it will be inclined like this. Okay? And it remained constant up to this point. Well, so the question is, at this point, from this point to this point, did it remain constant or not? Okay? So here, the diagram is supposed to come to 7 kilonewton. Okay? And just immediately after this, okay, because it is a shear force, immediately after this, there is a sudden change. it went down. Okay, sudden change, then it remained constant at 7 kilonewton. That's what you're supposed to take note of. Okay, yeah, it did not remain constant at this point. It's changed. From this point, it went down within that same span. At that point, it came to minus 7 kilonewton. So make sure that is corrected in your mind. So this is what we are calling a shear force diagram, SFD. Let us now see the bending moment diagram. Mind you, don't forget, we have drawn it on this side and the sign is negative. Okay? So you must put the sign, don't forget. Then let's draw the bending moment diagram. At this point, there are two things. You can draw it upward or downward. What is most important is the signs should not miss. Okay? We're going to draw it on the upper side. Okay? So in this case, our bending moment within the first span, it started from 0, and then at x equals to 2, it went to negative 3. So let's say negative 3 is here. Okay? Yes. Then from there, we came here. It remained what? Negative 3 when x is 2. Good. Then when x is 3, it went to minus 6. So let's say minus 6 is here. And within this span, when it is 3, it remained good. Then when it is 4, it became minus 13. So minus 13 is here. For the UDL, the bending moment, it's supposed to be a curve, and it's going to curve like this. Okay? Just. It is supposed to be a curve like this. Hope you have got it. Okay? Well, then at this point, our bending moment diagram will increase from this to this part, which is minus 6 kilonewton. Okay? Not a curve now, but just a straight line. Okay? Yes. So at this point is 3, this point is 6. Okay? Then at this last one, when x is 4, it went to 9. Minus 13, I mean. So minus 13, so straight also. So this is minus, it is 13 kilonewton meter. So most important thing is this curve. Okay? Yeah. So this is our BMD. You can shade it if you wish. But now the thing is, all these are negative. If it is positive, as you have seen in the previous videos, I'm drawing it downwards. But even if you draw it other way around, still it is correct. Okay? Yes. So we have come to the end of this video. Thank you so much for watching this video till the end. Please do like the video, comment, subscribe to this channel so that you don't miss any of my videos, and share with your friends.